All right, welcome to WASA Distance Education. This is MBF3C, grade 11 college prep math. And I'm Pete, I'm your teacher, and we're in sort of getting towards the end of week 7 of 9. I guess we're halfway through it today. So we're in Unit 4, so if you have your Unit 4 handout, you'll need that. If you don't have it yet, you really need to get your DEC to give you a copy of that. All right. So yesterday we started Unit 4. Unit 4 is all about statistics and data collection, data management, those sort of concepts, right? It has a big title. We call it data management in mathematics, but really there's a lot to it. There's collecting data, there's analyzing data, and then there's presenting data. Okay. And data, it's the same thing, just different pronunciations. No one's going to say you're wrong. Well, they can, but they wouldn't be right. So yesterday we started Unit 4, and really I spent most of the class trying to really make clear what a population is, because it's kind of key to this whole thing, that you have to understand that population is the group of things or people that we're studying. They could be people, or they can be items. They could be light bulbs, for example, right? And uh, yesterday we kind of got as far as the last couple of support questions, and then we went into the key questions were next. I think we should really finish those off, and then we're going to take a couple classes to actually do the next lesson, lesson 17, because it's statistics, and we want to make sure we cover it thoroughly. Okay, so that's where we're at. If you have any questions, you're always welcome to contact me at WASA. You can call me through, just on a phone, Facebook, PW space WASA. Okay, and I put my cell phone number in the study guide. So if you want to contact me, you can text message me through my cell phone. That's probably the best way to reach me, by text message, if you're going to use my cell phone number. Okay, so here we go. Last unit. We're on page 4 here of lesson 16, so unit 4. And yesterday we looked at the support questions, and they want 3 things from us for the support questions. They want to state the population about which information is sought, name the sampling method, and explain whether the sample is random or biased. These can be kind of tricky to figure out, right? We decided maybe that things might be a little biased on for A, just because of the nature of the way they were gathering the data. They sent it to this list of Canadian businesses, which I guess is a list of, I don't know how you get on that list, but it can't really be everybody. It wouldn't probably include government workers and probably not teachers, and who knows if maybe sports teams, stuff like that. So there is some, it's not really all that random. Okay, even though it seems to be random, they're choosing randomly, but from a biased list, right? And then, the sampling method. It seems to be self-selected for that first one, doesn't it? Because whoever opens the envelope, either they're going to send it out to people, or maybe they're going to do it themselves, right? We talked about the idea that maybe the reception would fill out the questionnaire, or maybe it'll be the boss, or maybe it'll be everyone in the company, depending on who handles that questionnaire. So that's a little dodgy, and that's what we have to guard against when we're doing surveys. Now, it doesn't mean that we can't do surveys that way. It means that we have to be careful. Right? We have to watch and understand the data that we collected. Right? If we ask students, for example, whether they want homework or not, right, at a school, chances are it's going to be pretty strongly biased towards no. Okay, so the question is, are those the people that that we should be asking about homework? However, if we ask students about, do you think the homework helps you? Is the homework too long? Is it too easy? Should we give homework every day or twice a day? Those are questions that we could legitimately ask students and get some good data from it. Okay. Now, let's take a look at um, support question 2B. It says to find out whether new items should be added to the school's lunch menu, 50 students are at random. Okay, this is the four-step problem-solving model. I'm trying to understand the problem. At random, chosen from 200 students in grade 8, okay, 225 students in grade 9, and 175 students in grade 10. Okay, so they pick 50 students and get them in a room and they say, all right, here's a survey for you, right? You know, which new item should be added to the lunch menu? Now, it seems like it's a random thing, right? But the problem is that it's randomly chosen from the 200 students in grade 8, okay, 225 students in grade 9, and 175 students in grade 10, right? So the question is, does the makeup of that random sample accurately reflect the proportion, the percentage of students in each of those grades? And it probably won't, right? There'll probably be an equal number of students. If you do it randomly like that, then you're going to have an equal number of students from grade 8 as grade 10, right? As a matter of fact, you probably, if you just picked it just strictly randomly, you'd probably end up with what, about 12, from grade 8 and 12 from grade 10. Did I get that? Yeah, give or take, 12 or 13. And that's not correct. There are more students in grade 8, and there's actually more students in grade 9 as well. So basically, grades 8s and 9s will be underrepresented in that method, and then the grade 10s will be overrepresented. They'll have more say in it. There'll be more students from grade 10 than really is proportionate. So it is what's the population? The population of students in the school, okay, that's fine. The sampling method is random sample, okay? And so it's not stratified sample, it's just a random sample. And if it was stratified, we'd determine what percentage those 200 students in grade 8 were from the total, and then figure out what, percentage of our 50 students, well, that same percentage of our 50 students have to be from grade 8. Then it would be a stratified sample. So rate, as it's stated, it's going to be just a random sample. And it's biased. It is random, and that's the thing. This question is kind of says whether this sample is random or biased. It's biased in the sense that grade 10s will be overrepresented and grade 9s will be underrepresented in it. So in that sense, it is biased. Maybe the grade 9 students, they still, maybe they have, their the taste from elementary school, maybe like SpaghettiOs, and stuff like that. Maybe grade 10 students, they might be starting to develop more sophisticated. Maybe they like chicken burgers and, vegetarian stuff. But who knows? Maybe. Maybe not. Maybe it'll be SpaghettiOs across the board, right? And that shows you just how difficult it is to come up with a really good survey, right? And it explains why sometimes things just go horribly wrong. We talked about the new Coke yesterday. We talked about the fact that every once in a while McDonald's has to kind of backtrack and stop selling something that they thought was going to go well. And that political polls are probably the worst of them, because pretty much you can find a political poll that predicted the outcome, and you can find 10 of them that got it completely wrong for every election. So it just it's the nature of polling, and polling is just a type of data collection. Okay. Now let's take a look at this C. This one might be a little easier to sort out. To determine the quality of light bulb produced, every 1,000th bulb is tested from the production line. Okay, so the population. What is the population there? The population there are light bulbs. Okay, that's the population. So the population can be a thing as well, right? We're going to collect data about something, and the target of that data collection, in this case, is the light bulb. Okay, is tested, right? They're taken off the production line. Now, depending on how the testing goes, they may or may not be able to put it back, right? Now, the sampling method seems to be, it's the one that's nth, right? Every nth sample. Let's go back a couple of pages here. systematic sample. There it is. It's called a systematic sample, where we're taking every thousands, and that's probably okay for light bulbs. They probably make a lot of them, right? So every 1,001 they pull off. That makes a certain amount of sense. Now, you know, do they let a few go by when the machine first starts in the morning, and then start counting, or do they just put the 1,001? I think by the time they made 1,000 of them, maybe the machines are all nice and running the way they should be. So now they're going to take that light bulb. Is it random? No, it's not really random, is it? Well, it's it's every nth one. It's not biased, right? It's unless there's something special about every thousandth bulb. Okay. So every nth. There you go. Now, what are they going to do with that light bulb? Well, they'll take it off. They'll probably plug it into a socket, make sure it lights up, make sure it doesn't catch on fire. Very important, right? Maybe they'll put some sort of meter on it to make sure it's producing the amount of light that's stated on the box, right? I think lumens is how they determine those. If it's too bright, if it's not bright enough. Some light bulbs also advertise a certain color of light, right? And then it's a scale that they use, and so they might even check that. Depends on whether it's it's going to be a premium bulb or not. What else might they do to it? They might actually say, well, okay, what happens if we put too much voltage through it, and then they put too much through it, and then see what happens, because maybe that's part of a safety, right? Does it catch fire if we put too much voltage through it, or does it just stop working, right? The other thing they might check is to see if the outside of the bulb, if there's any live electrical, activity there, because if someone is changing the bulb and they forget to turn the power off, maybe they don't want that person to get shocked, right? These are things that manufacturers have to be concerned about, but they're not going to check every single one. It's not cost effective, and it really doesn't make sense, because chances are, if you're using an assembly line, probably every single one that they produce in a batch is going to be pretty much the same. Okay, so that's it. That one's maybe a little clearer. Light bulbs is the population. Sampling method is every nth. What do they call it? I go back. Systematic. Every nth. And then is it random or biased? It's not exactly. That, that one's tricky. Let's see what they say at the in the back about that one, because to me it's it does seem kind of random, because they're picking every 1,000 bulb, but then there is a system to it. So let's see what they say, just kind of out of curiosity here. For key, it's lesson 16. All right, let's gotta find this at the back of unit 4. The answers. Do they even have the answers? I have some of them anyway. 18. Okay. Okay, lesson. So 2. C. Okay, so the population of all light bulbs produced by the company. It's a systematic sample. The sample is not random, but representative of the population. So the sample is not biased. Oh, okay, so that's what they're saying. So it's the way that they stated part 3. They said whether the sample is random or biased. They're not saying it's either or. It could be random and biased, or it could be systematic and not biased, which is exactly what ended up being the case. Okay, so there you go. That's kind of important to understand that. Okay, so now when we take a look at the key questions for this unit, there aren't that many, so for this lesson. So, but this is the type of thing we want you to think about, right? So a suggestion box is placed at a restaurant's cashier to attain customers' reaction to the new menu. What is the population being surveyed? Okay, so that's the first question. Okay, what is the population? What type of sample is this? Think about standing, and you may have done this before, right? Maybe you're standing there at, if you visit Suluca, maybe you go to Dick and Nelly's, maybe you go to the Forest Inn, maybe you go to the Fifth or Chicken Chef, and as you're standing there, you notice there's a little card that says Customer Satisfaction Survey, right? Have you ever filled one out? What circumstances would you, why would you fill one out, right? What type of sample is this? Is the sample biased? Okay, so I'm looking for your opinion. And again, you know, you could make a case either way. For C, you could definitely make a case either way. So this is where you get your marks right there. That's the explain part. Okay? I'm not asking for you to, I'm not looking for an agreement or disagreement on it. I'm looking for you to state an opinion and then justify it using what you've learned in the lesson. Okay? So support your opinion and you'll get the mark. Question 2. Explain why a sample obtained from friends and family is not representative of a population. Okay, here's the thing. Let's say I go down to colors here and see Lookout, and I got a new haircut. Okay? And then I go and I ask my friends and family, so what do you think of my new haircut? Okay? And they all say, man, that's great. That's a great haircut. Suits you. Okay? Now the fact is, maybe it's not a very good haircut. Nobody is going to tell me, well, at least not my friends, are going to tell me it's a bad haircut, right? No, they're not going to tell me, right? So that's, maybe that's the sort of thing they're thinking about, right? Um, what, or maybe if you ask, maybe you're asked to bring some food to a potluck, and you ask your friends and family, should I bring cheese pierogies, right? And all your friends say, yeah, those are great, those are delicious, right? Maybe all your friends and family like cheese pierogies. Maybe, the general population doesn't. We don't really know, right? We sort of have a little bubble of friends and families that kind of support us and share our common interests, right? So, so basically, again, I'm looking for an explanation there. Now, it doesn't even give you how many marks that whole thing's worth. So, but make it a few lines and try and explain. Make your point. Okay? And they're asking you to take the not. It's not representative. So that's it. I gave you a couple of examples. Okay. So here we go. And the rest of them are pretty well. I think the rest of them are pretty self-explanatory. All right. If you have any questions, certainly you can contact me. Okay. Yeah. So the rest of them are about schools and factories and stuff like that. Okay. So let's take a look then. We can start lesson 17. Okay, now we're going to take our time on lesson 17 because there's quite a lot to it. And for someone who's studying college prep grade 11 math, you probably really haven't seen this material before. You might have looked at it a little bit back in grade 8, grade 9, but you really is probably fairly new. So don't be alarmed if you see a bunch of new stuff right there. Okay. So, all right, we'll take this slow. And really, the types of questions that they ask you to solve are pretty straightforward. Like they're not tricky questions on the exam or in the key questions. They're all pretty much the same as these examples. Now we have a problem here, and the problem is that okay, I'm feeling a little bit. One of these, there it is. There's a mistake here, and I I fixed one copy. It looks like I didn't fix this copy. Okay, let me just try and find that. There's a mistake in one of the examples here, or did I fix it on this? Let's see, page 7. Okay, let's see, 5, 3, yes. Okay, so I fixed it in my copy, and it's not fixed in this copy. Sorry about that. So there's an extra 1 right here. So it's 3, and then it's 1, and then it's a squiggly bracket. So sorry about that. And it's actually copied down here as well. 1. Okay, so page 7. Page 7, Unit 4, this amount of data here, there should be 13 items in this list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13. So it was missing a 1 at the end. It was all, it looks like a cut and paste error or something. And unfortunately, it looks like I fixed it on my book here and didn't fix it on a slide. Okay, so but that's the sort of thing you'd sort of note as you're kind of, whenever you're going through an example in a math textbook, there's a lot of them have problems. No matter how careful we are, somehow all these mistakes. This looks like an editing mistake. All right, well let's let's back up a little bit. So what we're doing here for a lesson for lesson 17 is we've talked about, in lesson 16 we talked about collecting data. Okay, so now we have a big pile of data. It's sitting there on the floor. It's a big pile, and now we have to go through it all and do some analysis of it. We have to figure out what it means. Okay, and that's really it. So what we're going to do first is we're going to look at the different ways of analyzing data, kind of the big picture analysis, and then we're going to go and actually figure out how to use that. Okay. Now, this data analysis, sometimes it's actually, sometimes we'll put it in graphs, pie chart or something like that. And it can be really, it can really change how you look at things, right? I remember years ago, and this is a long time ago, before I was a math teacher, I was an engineer. So I had a problem I was trying to figure out with a piece of hardware and some the interaction with software. And I made a collection of data. I made a bunch of XY graphs, right? So we'd stick a number in the hardware with our software. We'd give it a number, and it would produce a certain power output. Okay, and it wasn't working quite the way it was supposed to. So I went into the lab and I collected a whole bunch of data. And so I probably had about 50 or 100 XY graphs at different frequencies. Okay, and I was sitting there late at night. It's probably about 10 o'clock at night in my office, and I'm trying to figure out what this means. I'm flipping through the pages, trying to see a pattern there. And one of my colleagues walked by and walked in, and he said, "What are you doing?" And I explained it to him. He said, "All right, give me a minute." And maybe about 3 minutes later, he sent me an email which had a graph. And what he did was he took all of the two-dimensional XY charts that I was struggling to see, and he made them into a 3D map, like a 3D model. So it's a surface rather than a bunch of graphs. So instead of a slice of a whole bunch, a bunch of slices, he put it all together into a kind of a solid model. And immediately, as soon as I opened it, not even a second later, I could see the problem, right? And I knew exactly how to fix it. And that's the thing. I could have sat there for hours, and I might have figured it out, but being able to visualize data, right? Even if you don't necessarily analyze it, he didn't do any analysis. He just put together the data in a way that made it more meaningful, right? And that was actually when I learned that Microsoft Excel, which I've talked about a few times, it'll make XY graphs for you, but it will actually make these surface plots as well. So if you have a bunch of XY graphs, you can actually get it to make a surface and see what they look like kind of all side by side. So 3 dimensions instead of 2. It might be hard to visualize what that would look like from my explanation, but it really is, it's worthwhile to study how to represent data. Okay, if you can do that, a lot of bosses will really value you, right? If you're, working, in an organization and they have to analyze data, if you can make very clear charts and very clear summaries of data, then you'll be very valuable. Okay, so let's talk about measures of central tendency. Okay, now, so often when we have a set of data, there's a simple analysis that we can use to get information about it. Okay, so we're often interested in the center of a set of data. Okay, and strangely, there are different ways to measure, to calculate the center. And we call these measures of central tendency. Okay, so there's 3 different ways that we're going to talk about. Okay, there's the mean, which you may be familiar with it. That's the average as well. Okay, so let's say that you get all your math marks back, and your teacher gives you your average. Okay, what your teacher is actually calculating is the mean. We call it mathematically the mean. In the text here, for some reason, they call it the mean average. I don't really know why. I just call it the mean. Um, okay, now. Um, Now, all three of these, the next one, sorry, is the median. We're gonna look at these. Okay, and then the third one is the mode. Now, all three of these um, measures of central tendency are between the largest value and the smallest value in a set of data. And there is a good reason that we have three methods. Okay, it because it can not only can it tell us something about the data itself that we're looking at, or the thing we're looking at, but it also tells us a little bit about the quality of our data, because sometimes we have data and it's really not very accurate. Okay, and I talk about that a fair bit when we're doing the trigonometry, about rounding things off, and that you can't use more decimal places um, than what you're provided. And that's, again, that's data, because you're basically giving a false impression of the precision of your answers. Okay, so it is very important that we, in addition to being able to analyze the data, that we be able to tell, there's something wrong here, right? This data just doesn't look correct. A good example, if I have a math student that's getting 80s, right? They're getting 80s, and they keep getting, they get 85, and they get 78, and then they get 83, and they get 81, and then they hand in an assignment and they get 49. Okay, so that tells me that something's wrong, right? And so, that's not necessarily their normal result. So I would take an extra interest in that and say, well, what happened, and try and fix it, right? So we, even without doing much analysis, we can sometimes tell that our data is a little dodgy. All right, so let's talk about the first of the three ways that we're going to measure central tendency. So the mean, and it's a single number, it's an average. Okay, and you're very used to that probably from school, right? And okay, so what we do is we take a set of data. Now, in the text and in most math texts, when we have a set of data, we just write them as a list of numbers separated by commas, and then we put these curly brackets around them. Now, when you're going to write it's the worst curly bracket I think I've ever made. All right, maybe the second worst. Okay, there you go. So this is what the curly bracket looks like, and if you're typing it on your keyboard, it's going to be the shift, it's right to the right of the P key on your keyboard, and it's just shift. Right? If you just type the ones beside the P, you'll get square brackets, but when we're listing a set of data, we use curly brackets. Okay, so it's just basically it's like that, and then it's like that. And you know what? If you have a hard time making curly brackets, use square brackets, use parentheses. I don't really care. Okay, but it's common to separate them and put them in curly brackets. Okay, now the way we calculate the mean is by adding up all of the uh, numbers in a set. You just add them up on our calculator, and then we divide that by the number of members of the set. So if we take a look at A here, we have 1, 2, 3, 4, 5, 6, 7, 8 members of that set A of data. We don't know what those are. Those could be hockey scores or curling scores, golf scores. No, not golf scores. Anyway, we don't really know. It's just a bunch of data. And then we divide that by the total number of items in the set. So in this case, it's 8. Okay, so we're going to take them at face value that they added up all those numbers 1 through 11, and then it ended up being 50. And then we divide it by the number of members in the set. So the mean in this case is 6.25. Okay. Now, sometimes in a set of data, very often in a set of data, we have the same numbers repeated. Okay, so don't let that throw you. It's not a mistake. It's just sometimes we have the same number. Think of your test scores, right? If you had a quiz every Friday in math, or let's pick another subject. You had a quiz in gym. Let's say you had a quiz in gym every Friday, and so out of 10, maybe you get 10. You get 10, right? And then maybe you get a 9, and then maybe you get an 8, right? And then you decide you're going to do better in your quizzes, and you get a 9 and a 10 and a 10 and a 10 and a 10. So that can happen in some data, right? And generally speaking, we're going to have repeated. Now, they're not usually in numerical order. For whatever reason, they decided to put that first set in numerical order. And for some types of analysis, we do have to put them from lowest to highest in order. But that was a coincidence. If we take a look at B, B is just the random order. So we have a 4 and then a 7 and a 3 and a 5. Okay, so we don't necessarily have to put them in numerical order. Now, in case you're wondering, this seems kind of tedious, doesn't it? Right? Adding these all up and dividing. Excel, if you have to do any kind of data analysis or statistics or anything, Excel is the tool you want. And you can just get help online, no problem at all with Excel. If you want to know how to calculate means in Excel, you just type mean Excel, and there'll be videos on it, there'll be written pages on it, and you'll get all sorts of help. Okay, that's what I would do if I had to do a bunch of. As a matter of fact, that's how I keep the marks. I have, dozens of students and a dozen courses that I'm tracking, hundreds, if not thousands, of pieces of work that have a mark attached to them, and I keep track of all that in Excel. Okay, and I collect my statistics that way. So, for example, if I needed to find the mean of a set of numbers, I could do that. And if I needed to sort them in numerical order in Excel, I could do that as well with a push of a couple of buttons. Okay, so it really is worth it. And, if we have some time left over here, we can certainly look at using Excel to do this sort of thing. Okay, so for B then, we're going to calculate the mean by just listing all the numbers, right? We add them all up on our calculator, and then it will divide by the number of members in a set. And that is how I figured out that we were missing a number there. I counted them all because it's just a good thing to check anyway. And it turns out we were missing one. So we add them all up, 60 divided by 13, and then we have 4.62. Now in this case, notice that they used the squiggly brackets, and that means approximately equal to. Anyway, it means approximately equal to. And it's two squiggly lines stacked one on top of each other. Like that. Okay. And that really warns someone when they see that there's more digits available. We've rounded it off just for the sake of convenience, and usually 2 decimal places is plenty for something like that. All right, so here we are, support questions, and they're just asking us to repeat that. It's worth trying a few of these. It'll sort of point out if you have any issues, with your calculator using doing a whole bunch of numbers like that. Okay, so let's try that. I'm just going to make a new page. This is the top of page 8, and let's just try A here, 1A. So 1A, and so the mean. All right, so the mean is equal to, and it's just going to be 3 plus 6 plus 2 plus 7 plus 3 plus 5 plus 8. And then there's 1, 2, 3, 4, 5, 6, 7 items in the set. Okay, now I didn't make my line really very good there. There you go. So 3, 6, 2, 7, 3, 5, 8. Okay, I think I got that. So now I'm going to add those up, and we're going to end up with a fraction. So let's see here. Okay, 3 plus 6 plus 2. Now, some calculators, you can edit the if you make a mistake or something, you can go back and edit the entry. Those are really handy calculators. So it's 34 divided by 7, so divided by 7, and we're going to get some big long number here, 4.86. That would be the, and I'm just going to say approximately equal to 4.86. I just rounded it to 2 decimal places, just following what they did in the text. Okay. Now we can double check that with the back. If you go to the back page here, they have all the answers to these. Those can be very, very helpful. So lesson 17, support question 1. And you see that's on page 28 near the bottom there, and it shows you it's 4.86. Now, the text doesn't really say this, but in statistics, an X with a line over the top of it means the word mean. That's what it means. means, right? So I could, if I wanted to, instead of writing mean right there, I could have said X equals whatever. Okay? And then at the end, I would say that X with a bar over it is, now I'm going to have to fix that a little squiggly. X is approximately equal to 4.86. Okay? So that's what it means, that X with a bar over. And you'll see that at the back of the book and in a couple of places in the text. But it looks like for some reason someone probably didn't want to introduce that symbol, but yet it sort of snuck in there. So it's probably good that you see that. The X with a bar over it means mean. Okay. Now let's take a look at the next one. Okay, the next one is called the median. Okay, this one's a little easier actually. Okay, so the median is the middle number in a set of numbers. Now, here's the important part: arranged in numerical order. Okay, so now in some data sets, if there's an even number of values in the data set, there's actually going to be two middle numbers, right? So in that case, then we basically find the mean of those. Okay, I know it seems yeah, it sounds complicated. It's actually, that one's probably easier to figure out than the mean in a lot of cases. Okay, so let's take a look at an example will really help you understand it. So that's called the median. So that's on page 8. Let's go back here to page 8. There it is. The median is the middle number of a set of numbers arranged in numerical order. Numerical order. Okay? If there are an even number of values, right, in the set of data, there will be two middle numbers, right? And then you're just going to find the mean of those. You're going to find the average of them. Okay? All right, well, let's try the example, and I'll do my own page here. You can follow along on page 8 here. Okay, so example 2, this is example 2 from page 8. Okay. And so our set A is going to be like this. It's 7, 9, 12, 17, 8, 3, 11, and 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so yeah, I have enough. That's one of my quality control things when I'm writing down a list of numbers. Count both lists, make sure I have the same number, right? And that at least will detect if I've missed something. Okay, so we're going to, wait a second, 1, 2, 3, 4. Oh, I missed it. It's not one. It's not 17. I did the same thing twice, didn't I? All right, let me write this down again. It's 7, Try this again. Yeah, talking about quality control. So it's 1, 7, 8, 3, 11. You probably caught that. I'm still sitting here going, oh, what's going on? Because what was sort of troubling me was that this is the easy case, which is that there's an odd number, right? So there's an odd number of values in here. Let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's an odd number of values in there, which means there is an actual middle. But before we find the middle, we have to put them in numerical order. So the way I'm going to do it is I'm going to take, okay, there's a 1, I'm going to cross it out. Now we'll find it, there's no 2. So now I'm going to find a 3. Now be careful, there may be another, like values may be duplicated. There isn't one, so there's a 4 there, right? Okay, no 5, no 6. Okay, but there's a 7 here, and then there's another 7 there. We got it. And then there's an 8. We got that. There's a 9. There's an 11. Yeah, and then there's a 12. I think you can see why we would prefer to use Excel. What we would do is just type that list in and then push a button to sort them in numerical order in Excel. Much, much quicker. Okay, so let's make sure we still have our 9 in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, perfect. And now they're in numerical order. So now we're going to look for the middle number. Okay, so with 9, that means I got 4 on one side, 4 on the other. That means that that is the middle number. Right? Okay. So that is the, here, lost my, so we got the median. So that is the median. And that's just it, right? So pretty straightforward when there's an odd number. You just rank them in numerical order and then count in from each direction. Well, I mean, you know which to, you know, if you have 9, right? 9 divided by 2, you know, it gives you 4 and a bit, right? So 4, you skip over 4 and then that one's your median. Okay, middle number. Well, let's take a look at what happens when it's an even number of values in a set. Okay, I'm just going to extend this page. Okay, so this is going to be B here. Let's see if I can get this a little better. So it's 4 and 7, 3, 5, 1, 8, 3, 9, 4, 7, 5, and 3. There we go. Okay, and I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Got it. Okay. So, I'm going to do the same process again. I'm going to go through, and we have 1. That one's gone. No 2. I got a couple of 3s there. 3. 3, 3, a couple of 4s, a couple of 5s. Okay, writing get a little sloppy when I'm doing this. Okay, no 6, a 7. Yeah, we got that. Another 7, and I got an 8. There we are. All right, so we have, was it 12 members of the set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a 9. Haha. Okay, that's good. That's what I like about mathematics. You can, there you go. Look at that. Okay. So, if we had just built a building just now and somebody goes, it's a little crooked, then we'd all be kind of looking at each other, don't know. But the nice thing about math is you just erase it, cross it out, write the right value in, and nobody's the wiser. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's 12 items in the list. That means that we can separate them. If I go 5 here and 5 there, it means there are 2 middle values. You see, the middle is actually right between the 4 and the 5, isn't it? So what we really want is the mean of 4 and 5, right? The mean, x, remember how we calculate the mean? It's the numbers in the set divided by the number of values. Okay? So that's the mean. Okay, 4 plus 5 is 9. 9 divided by 2 is going to be 4.5. Just a little over eager there. 4.5. And there we go. Okay, so that's the mean, and it's also, going to extend the page a little bit, and then it's also the median. Right here. Okay, so that's how we do that one. Okay, so the mean is the average, or you add them all up, divide by the number of values in a set. The median is the middle number when they're ranked numerically. If there's an even number, then you pick the 2 middle numbers and just find the median of them, right? Add them together, divide by 2. All right. Well, that's not so bad so far. Okay. And the last one actually isn't too bad either. The last one is called the mode. Okay. And the mode. Let's go back here. Okay. Is it no? Okay. So we'll just flip forward to page. I think we're page 8, right? Yeah, page 9. Okay. So we're going to take a look at the mode. Okay. Well, we can do a couple of these if we'll come back and we'll do a couple of those tomorrow. The mode is the most common value in a set of numbers. Okay, so that it can be a little sort of tedious to find it, but basically you're going to do the same thing for the mode as you do for the median, which is rank them in numerical order. Okay? Rank them in numerical order, and then you find the number that's repeated the most. Now, here's the thing, and it's a little bit of a kind of the text kind of leads you a bit astray here because it says the most common value in a set of numbers, right? In fact, you can have more than one mode in a set of values. If there's equal numbers of the same value, right, then you can have multiple modes in a set of values. Okay. Okay, and the condition is that the number of repeated values has to be the same, right? So in a set of values, if you have, let's say that you have a 3 that's repeated twice, and 5 that's repeated twice, and 7 that's repeated twice, and then no other values are repeated twice, then you would have 3 modes, the 3, the 5, and the 7. Okay? But if you had one set of values of those that was repeated 3 times, and then others are repeated twice, you only have one mode. Okay, so it's not the number of, it's not the fact that you have a value repeated, it's the most repetitions. And now if there's a tie, right, in the number of repetitions, then they're all modes, right? So okay, R. Oops, R. Whoa, okay, I think I gotta break out the eraser here. Got another good mathematical tool, probably used more than anything else. Okay. Any ties in the most repeated are also modes. Okay, so it's only when we have ties. Okay. Now, let's take a look. We'll do some examples here. So example 3, let's just actually, you know what? We'll look at example 3. We'll actually do some of the practice questions afterwards. So find the mode in the following set of numbers. So let's just look through this. Actually, we don't really have. We'll just kind of get started with this, and we'll go again tomorrow. So it says find the mode in the following sets of numbers. So we have a set of numbers. Now the first thing we're going to do for A here is arrange them in numerical order. And that just makes it easier to pick out the duplicates. And usually we have to do that to find the median anyway. Okay, so now we have them arranged in numerical order, and we see that 7's repeated twice, and there's nothing else that's repeated twice. So in this case, the mode is 7, right? So, and that's pretty common. If I gave a quiz, right? If I gave a math quiz out of 10, okay, and I found the mode for that, maybe, chances are the mode might be 8, right? Because maybe 5 students got 8, and then, some people got 10, some people got 5, right? So that would tell me something about the quiz, right? Especially if the mode was 10, right? That would tell me it's a very easy quiz, right? If the mode was 10, most students were getting 10, tells me it's very easy. If the mode was 5, then that would tell me that probably the quiz is a little too hard because most students are not getting, they're getting 5 out of 10. Or it might tell me that I'm not, not teaching it, uh, whatever's on the quiz. Maybe I forgot a step or forgot to teach them something. Okay, so that's how you find out the mode. Now, in a case like this, for B, you notice we have repeated 3's, we have repeated 4's, 5's, and 7's, but you see the 8's are repeated 4 times, which is more than any other value. Okay, so the mode is going to be 8. And there's only one mode because there's no other value repeated 4 times. Now you notice the 3's are repeated 3 times. If there was one more 3, then it would have 2 modes, 3 and 8, but there isn't. By the same line of thinking, if the 8's weren't there, then our mode would still be 3, right? And if the 3's weren't there, then we'd have 3 modes, the 4's, the 5's, and the 7's, because there's 2 of each. So that's how it works. It's basically the most frequent value in the set, and if there's a tie with the most frequent value, then all the ties are modes. Okay, so, and I think that's probably where we're going to leave it. We'll come back tomorrow, and what we'll do is we'll continue working on these. We'll do some more of the support questions, and I think I skipped over the ones for median, so we'll go back and do those. And that's it. There's a lot of adding up a long list of numbers in this, but it is worth it. And this data analysis there's some pretty good skills. All right. So yeah, so we'll wrap things up today, and we'll see you in the morning. Okay. Okay. So we have to kind of. All right. Okay. Yeah. All right. So we'll wrap it up.